2014 question number 4 starts off by giving us some information about train A and giving us a table of values for time and the velocity of train A. Now remember, velocity is the first derivative of position, and that's going to be important later on. For this particular question, A and B are pretty simple actually. Things start to get hard once you get to C and D. So I'm going to try to go as fast as possible with A and B so I can spend more time with C and D. So part A is asking for the average acceleration of train A from 2 to 8. Well, acceleration is the first derivative of velocity, right? Velocity to acceleration. But I have the word here, keyword average. Anytime you hear average rate of whatever it is, it's your basic algebra 2 slope. So y2 minus y1 over x2 minus x1. You can evaluate v of 8 minus v of 2 over 8 minus 2, and you're simply going to get negative 110 over 3 meters per minutes squared because it's acceleration. And there's only 1 point for the answer. 1 point for the answer. And again, you saw how simple it is. Average rate of whatever it is. The fact that it's average means that you're going to use your algebra 2 slope. Part B, it's asking whether or not it's possible for train A's velocity to be negative 100 meters per minute between 5 and 8. Well, you have to remember that in calculus, we like to study continuous functions, things that connect. So if I have this function here, right, that has the minimum value is 2 and it goes up to 5, I know that at some point in the middle right here, I'm going to have a y value of 3. If it's continuous and it's flowy, which it is in this case. As here, this is a continuous and differential equation. So I know my velocity at 8 is negative 120, velocity at 5 is 40, and negative 100 is in between these two values. Just like here, 3, for my example, you don't need to include this in your answer, but for my example, illustration purposes, 3 is between 5 and 2, so I know 3 is going to be included in there. Likewise, negative 100 is between a velocity of negative 120 and 40. And because it's in between there, keyword, big concept here, intermediate value theorem. Just simply states that if f is continuous and whatnot, there's going to be a middle value that's in between these two bounds. So again, a very straightforward question worth 2 points. One saying that negative 100 is between these two values they want, 5 and 8. T is equal to 5 and 8. And then 1 point for saying that it's the intermediate value theorem. Just remember, intermediate is in between, and it's in between some two bounds you're looking at. Now, C is where things start to get hard. They want us to find the position of A at a new time t. And this comes down ultimately to the fundamental theorem of calculus, or fundamental theorem of calculus part 2, that is. And I'm just going to show you what it looks like here. Anytime we want something, t of 12, f of what we want is going to equal to f of what we know, something that they give us, plus the big word here, big concept, net change from what I know to what I want of the rate. If this is position, this is going to be velocity because the first derivative of f, etc. So what I know is that t is equal to 2. They give me t is equal to 2 is 300 meters. So I'm going to plug that in for now here. F of 12 is what I want. So my general setup without doing any work is f of 12, what I want, is equal to f of 2 plus the net change from x is equal to x is equal to 12, or t is equal, it doesn't really matter. But notice here, for my derivative, I put velocity because the derivative of position is velocity. Now here's a trick though. They don't give us a graph or equation that we can evaluate with an integral. They want us to use a trapezoid sum with 3 subintervals. Now the way I would approach this, I can ignore this column here because I'm only evaluating from 2 to 12, right? From what I know to what I want. So I'm going to ignore this column, and I want to divide this from 2 to 12 into 3 equal groups. So I'm going to group 140 here, 40, negative 120 here, and negative 120, 150, negative 150 here. It's better if I just show you what I did here. Again, for a trapezoid sum, there is a formula for it, but you can just understand the pattern. Each time I'm going to divide by 2, every time. What goes in here is my first 2, 140. Then I move over just a little bit, 40 to negative 120, and from negative 120 to negative 150. That goes in this column. This parenthesis over here, 3, 3, and 4, is simply the difference in time t. So 5 minus 2 is 3, 5 to 8 is 3, 12 to 8 is 4. That's where I get my values from. Again, it's more of a pattern. There was a formula to it, but better to just look at the pattern and understand it. Each time I divide by 2, this goes in as the combination, and 3 is simply the difference between that interval over here. Putting it all together though, f of 12 is equal to f of 2, not 2. Don't put 2 here. That's different. You're going to put 2 in here. But f of 2, the position it is, they tell us at t of 2 is 300 meters. So f of 12 is equal to 300 plus whatever this evaluates to, which happens to be negative 450. You add these up, and f of 12 is equal to about negative 150, or 150 west of the station, because it was moving east. East we consider positive direction going this way, west going the opposite direction, so either of these would work. Now this was worth a lot of points. 1 point for the setup, just knowing this formula, this equation, that's going to be your go-to route. 1 point for using the trapezoid rule. Again, you can look up the formula, or you can just use the concepts that I used up here, same thing. And finally, just 1 point for the actual answer. Now, D is one that a lot of students are going to struggle with. It's related rates. They give us another train, B, going north, and A is going east. Automatically, anytime you get related rates, always draw a picture, even if it's a horrible picture. We're not artists here, we're mathematicians. B is going up, A is going to the right, and they want the rate of change, distance between A and B. So they don't want the distance here, they want the rate of change, and that's going to be key. Automatically, saying that this is going to make a triangle, my equation overall is going to be Pythagorean's theorem. X squared plus y squared is equal to z squared. I'm going to differentiate with using implicit differentiation. And that's a big concept here, implicit differentiation. 2x dx dt, 2y dy dt, 2z dz dt, etc. I can cancel all these 2's because I can, it makes it easier. Now I'm going to evaluate at the instant t is equal to 2. They tell us at t equals 2, b is 400 meters north. And from part B actually, right, we found that at t equals 2, A's position is 300 north. So I'm going to get 300 here. This was from question C. I use Pythagorean's theorem, 400, 300, 500 for my z value. Now to get my rates, right, I plug into this formula, t of 2 for B, and I get A's velocity from this table here. At 2, it's 100. I rewrite here again, x dx dt, y dy dt, z. The only unknown I'm solving for is dz dt, and that's good. I have all this information now. This is all integrating every possible information from the question. I divide by 100, and I simplify at the end. Ultimately, they're going to get most of the points from using implicit differentiation, and only 1 point for the answer.